So we're asked to find f prime of a, which means the slope at an instant, the tangent slope at location a. And so they want us to use this formula. So just a quick intuition of what the formula says. It's saying, hey, here's a y-coordinate, and we're subtracting it by another y-coordinate, and that's over the x-coordinate, the corresponding x-coordinate subtracted by the corresponding x-coordinate here. Those are 2 points, right? But they're points that are getting infinitely close to each other. So you're finding the slope at an instant instead of the slope between 2 points. Okay, so we can just plug in what f of x is into the formula. It's just going to be some rational expressions we got to work with. Plug in 1 over x minus 2 in for f of x. And then f of a means you're supposed to plug in a in for the letter x. So I've taken care of the top part of this formula. Now the bottom part's nice and easy. It's just x minus a. Just watch out for the double negative there. Okay, so we can simplify the numerator. That's 1 over negative 3 minus 2, that's negative 5. And then x minus the negative 3, that's x plus 3. I dropped my limit notation too. This is the limit as x approaches negative 3. Because the whole problem right now is that usually with limits, like, we want to be able to just plug in what the limit is. We want to plug in negative 3. But we can't do that right now because we'd have a divide by 0 problem. So we've got to rewrite somehow so that the x plus 3 cancels out. And I'll get lazy with my limit notation. I'll just write LIM. Let's see. There's a few different ways we could go about this. Let's do 1 over x minus 2. This is the numerator, right? And that's minus a negative 1/5. I'm just going to change that to plus 1/5 to make it easier. And I'm dividing that by x plus 3. That's another way of writing what we have here. Instead of a fraction, I rewrote it with division notation. Okay? And then we can change this by flipping and multiplying. So it's the limit still as x approaches negative 3. 1 over x minus 2 plus 1 over 5. Think of this as a fraction. It's over 1, right? So I'm going to flip and multiply. And if I do that, I get the limit of 1 over x minus 2, x plus 3, plus 1 over 5, x plus 3. So we're getting closer. It's getting a little more simplified. We need common denominators. So I'm going to multiply the top and the bottom of this fraction by 5. That's the only thing that's missing, right? So trying to get common denominators. This is going to be 5 over 5x minus 2, x plus 3. And then when we're looking for common denominators, what's missing over here is we're missing an x minus 2. So I'm going to multiply the top and the bottom by x minus 2. And we got 5x plus 3 and x minus 2. Now we have the same things in the denominators, so now we can add the numerators. This won't move anymore. There we go. Okay, so the numerators can add. We're still doing the limit. And if we add the numerators, we're going to have x plus 3 in the top. And so that's the magic of the formula, is that's going to make something cancel out with the denominator. The x plus 3 is canceled, leaves us with just 1 in the numerator. So we got the limit as x approaches negative 3 for 1 over 5x minus 2. And now we can just substitute negative 3 in for x. Negative 3 minus 2 makes negative 5. Negative 5 times 5 makes negative 25. Negative 1 over 25 is our answer.